Hello friends and my dear students, welcome you all to my channel. Uh, in this channel, I make videos on mathematics from class 6 to 10 as well as 11 and 12. So this video is part of the playlist NCERT Maths 9, which means I will cover all the chapters of mathematics of class 9 following the NCERT textbook. This is the lecture 1 video from of the chapter 1, that is number systems. So let's get started. Okay, so in your previous classes you have already studied the different types of numbers like whole numbers, natural numbers and integers, and you have studied how to represent them on the number line. I will quickly recall the numbers, the types of numbers you have studied so far, and how to represent them on the number line. So first we have the natural numbers, or also known as counting numbers. So the collection of natural numbers is denoted by the letter n. So the natural numbers are 1, 2, 3, 4, 5, and so on. There will be 100 and so on, 500 and so on. It will go on. There is unlimited or infinite number of natural numbers. So these are the counting numbers or the natural numbers. So points to remember is that 1 is the first natural number, and there is no last natural number. Because the number goes on, there is unlimited number of natural numbers, it will go on. So these are the natural numbers. Then comes the whole numbers. The whole numbers are nothing. When you add 0 to the collection of natural numbers, it becomes whole numbers. So whole numbers is denoted, the collection of whole numbers is denoted by the letter W. This is nothing but we just add 0 to the collection of natural numbers. So points to remember is 0 is the first whole number, and there is no last whole number, because there is unlimited or infinite number of whole numbers. So when we say there is no last natural number, it means it uh, also means that there is infinite number of natural numbers, or there is no largest natural number. So 1 is the smallest natural number, and there is no largest natural number. Similarly, 0 is the first whole number or the smallest whole number, and there is no last whole number or there is no largest whole number. Now comes the integers. So the natural numbers and the whole numbers. Okay, so how do we represent the natural numbers or the whole numbers in the number line? So we draw a line uh, and we put an arrow on both the sides, meaning this line actually extends infinitely on both the sides. And on this line, at the middle point, we take a point, we label it as 0, which means the origin. Now, this origin is actually denotes uh, the value 0. So, all the points to the right hand side of the origin uh, denotes the positive numbers, that is the whole numbers, and all the numbers whole numbers. So to the right of the origin, to the right hand side of the origin will have positive numbers, and to the left hand side of the from the left hand side of the point O, we will have negative numbers. So this is 0, and we mark or we represent the natural numbers uh, by labeling it on the number line with points equidistant from each other. So from O to A, it's equidistant. It's the distance is 1 unit. So A, the point A, denotes the natural number 1, and its distance from O, point O is 1 unit. Similarly, from A to B, the distance is 1 unit, and the point B denotes the natural number 2. Similarly, we have 3, and so on. So this is how we represent the whole numbers, that is the 0.0, which is at the origin, and the natural numbers on the number line. Now comes the number integers. Now, what are integers? This all this you have already learned in the previous classes. I'm just recalling them. Now, integers are the whole numbers, but it also includes the negative of the natural numbers. So the natural numbers are 1, 2, 3, 4, 5, 6, and so on. So the negative of these numbers like -1, -2, -3, -4, -5, -100, -500, and so on, all those negative numbers and the whole numbers together make the collection of integers. So the collection of integers is denoted by the letter Z. Uh, so this collection is actually like if this is 0, we have 1, 2, 3, 4, 5, and so on, somewhere 100, and so on. Over here we have -1, -2, -3, -4, -100, and so on. So there is infinite number of since there is infinite number of natural numbers on the to the right hand side of the 0, there will be infinite number of such negative numbers to the left hand side of the 0. So all these numbers, that is the whole numbers and the negative of the natural numbers together, this collection is known as is this collection of integers. So for integers, uh, obviously there is no first or last integer, because to the left of 0 there is infinite number of negative numbers, and to the right hand side of the 0 there are infinite number of positive numbers. So there is no end to the left hand side and there is no end to the right hand side. So that means there is no start and there is no end. So there is no first or last integer. This also means that there is no least or there is no smallest, or there is no smallest or largest integer. Also notice that uh, all also notice that all whole numbers are also integers. All but not all integers are whole numbers. So all whole numbers are also integers, definitely, because the collection of integers includes the whole numbers as well as the negative of the natural numbers. So it includes the natural numbers and obviously the whole numbers. And so, but if you take any integer that may not be a whole number or that may not be a natural number, for example, if you take any negative number that is not a whole number or that is not a natural number. Okay. So, how do we represent integers on the number line? We similarly take the number line, we put the arrow, we mark the center point origin O, which denotes the value 0, and over here we have this is 0. So at equidistance, at unit distance, we have 1, we have 2, we have 3, we have 4. Similarly, on the left hand side, at equidistance, we will have -1, -2, -3, -4, and so on. So the point A is equidistant from O, the point B is equidistant from A, B denotes the value 2, A denotes the value 1, O center O always denotes the value 0, C denotes the value 3, D denotes the value 4, similarly E denotes the value, the integer -1, F denotes the point F denotes the integer -2, G -3, and H -4. Now these are not all the numbers that actually exist in the number line. What about what about a point in between A and B, or B and C, or C and D, or O and A, or E and O, or F and E? These numbers are definitely not integers, meaning they are not negative integers, they are not natural numbers, they are not whole numbers. These numbers are actually rational numbers, which we will now discuss. So now we see uh, what are rational numbers. What is a rational number? a rational number mm, is a number, any number that can be written in the form P by Q, where Q not equals to 0 and P and Q are integers. So a rational number is a number that can be written in the form P by Q, where Q is not equals to 0 and P and Q are both integers. Now Q not equals to 0 because in the denominator we cannot have 0. In mathematics we cannot divide by 0. So in the denominator we never have 0. That is the reason Q cannot be 0. So some examples of rational numbers are like 1 by 2, or let's say, or even 4 by 1, minus 3 by 2. So the first one half, 1 is an integer, 2 is an integer. The second one 4 by 1, 4 is an integer, 1 is an integer, even though 4 by 1 is actually a natural number or an integer. Minus 3 by 2, minus 3 is integer, 2 is an integer. Also 0 by 1, 0 is an integer, 1 is an integer, so 0 is actually 0, 0 is also a rational number. Likewise, minus 2000 by 101, this is also a rational number. Now, how do we represent the rational numbers on the number line? How do we represent rational numbers on the number line? So, let's say representing rational numbers on number line. Let's take an example. Let's say, how do we represent 2 by 5? So, we first draw the number line. Now, 2 by 5, any number in the form P and Q, and if that is not eventually an integer, like if P by Q is 4 by 1, if the denominator, if Q is 1, then it eventually becomes an integer. So I'm not talking about those rational numbers. We are talking about rational numbers where Q is not 1. So let's say 2 by 5. So what does actually 2 by 5 means? It is a fraction. It means if we divide a unit distance into 5 equal parts, then then 2 by 5 actually means 2 such equal parts together makes the value 2 by 5. This means actually, let's say this is a unit distance A of unit length, A, B. This is a distance of unit length. If I divide this unit length into 5 equal parts, why 5? Because 5 is in the denominator, 5 equal parts. Let's say the 1, 2, 3, 4, 5, 5 equal parts. Then 2 such, then 2 is in the numerator, so then 2 2 two such parts, this thing, this distance is actually 2 by 5. So, uh, yeah, so this is 2 by 5. Uh, so, if this would have been, let's say, uh, another example, let's see if it is 1 by 3. So, we have a unit distance, a unit distance, and we divide this distance, unit distance, into three equal parts, 1, 2, 3, and then 1 by 3 actually means one such part. So, this is 1 by 3. Now, let's see how do we represent 2 by 5 and 1 by 3 in the on the number line. So, we have the number line, the center is origin O, this is 0. The first thing we do is we mark some unit distance points like 1, 2, 3, 4. Now, 2 by 5 is definitely less than 1. So, it will lie, it is a value between 0 and 1. Also, 1 by 3 is a value between 0 and 1. So, let's say here is the point A. So, OA, the distance OA is of unit distance. Now, since I am trying to represent both 2 by 5 and 1 by 3 on the same number line, I have taken the unit distance a little larger so that I can draw them properly. It is properly visible. Now, to represent 2 by 5, so this is 0 and this is 1. This value is, this point indicates a 0. Level O denotes the point, the value 0, and level A, point A, denotes the value 1. Now, to represent 2 by 5, we need to divide OA into 5 equal parts. We mark 5 equal parts on the number line between OA. So, let's say this 1, 2, 3, 4, 5. Now, from 0, we take two such equal parts, two such equal parts. So, 1 and 2. So, this is 2 by 5. The rational number 2 by 5 is the point, this one. This is B. The point B now represents the rational number 2 by 5. Similarly, to represent 1 by 3, what we do is we draw the number line, we mark O, the center point, origin, this is 0, and let's say this is A, unit distance from O, so this is label A will denote the value 1. So 1 by 3, we need to divide this unit distance OA into three equal parts, 1, 2, 3, and now 1 by 3 means one such equal parts. So from origin we go one such equal parts. So this is 1 by 3. The point B in the second number line denotes the rational number 1 by 3. Now what about negative numbers, negative rational numbers? What about if you want to represent minus 2 by 5? So the negative minus 2 by 5 would be represented on the left hand side of the point O. So the same diagram, the same thing will actually be shown on the left hand side. Let's see if I can draw A. So if this is, let's say, this point is C, this is minus 1. So OC is unit distance. So this is minus 1. Now if I divide this OC into 5 equal parts. So 1, 2, 3, 4, 5. Sorry, just consider that these are equal parts. Let me draw it correctly. Mm, undo, undo, undo. Okay. Now I need to divide OC into 5 equal parts. So this is 1, this is 2, this is 3, this is 4 and 5. Okay. Now two equal distances, two such equal parts, 1 and 2. This point E, let's say E, will denote the value minus 2 by 5. So the minus 2 by 5 value, rational value, is actually the mirror reflection of the point B, and vice versa. The point B about the origin, about this point, origin O. So B is the reflection of E about O, and E is the reflection of B about O, meaning that they are negative of each other. So the same thing, if I want to represent minus 1 by 3 on the second number line, we will consider a unit distance. We will consider the C as minus 1, and then we will divide OC into 3 equal parts, 1, 2, 3, and then this point will be minus, let's say this point is F. So F now denotes the rational number minus 1 by 3 on the number line. So this is the basic concept. So if you are given a rational number, now what about rational mixed, what about rational numbers, like say these two rational numbers are less than 1? What about rational numbers, say mm, uh, let's say 11 by 2? This is also a rational number, right? P is 11, it is in the form P by Q. P is 11 and Q is 2. How do we represent this on the number line? So 11 by 2 is actually, if you uh, recall from previous classes, that 11 by 2 is actually a mixed, can be written in the form of a mixed fraction as 5 1 by 2, right? So 5 into 2 plus 1, 11 by 2, the 5 and a half, we call it as 5 and a half. So 5 and a half is a mixed fraction, meaning what is a mixed fraction? It has a whole part, that is 5, and a proper fraction part, that is half. So this is actually 5 plus half. So 5 whole units, and then if I divide a unit distance into two equal parts, and one such equal parts is half. So how do how will I represent 11 by 2 in the on the number line? Let's see. So this is the number line. We have the center point O as the value 0. Now 5 equal parts. Okay. So definitely 11 by 2 is 5 equal 5 whole parts, that is 5 distances, 5 plus half. So what is 5? 5 means 5 unit distances. So if this is a unit distance, let's say we have 5 unit distance, 1, 2, 3, 4. It is very difficult to represent this number on the number line. hmm. 1, 2, 3, 1, 2, 3, 4, 5 will be. Let's take a little smaller number. Let's say this number is not, uh, let's say this is, let's say this is 4. Let's say this is 4. So this will become, if I convert this into mixed fraction, this will be uh, something like this: 2, 2 and 3 by 4. So 2 whole parts and then 3 by 4 as a fraction, which means if I divide a unit distance into 4 equal parts, then three such equal parts will be 3 by 4. So this is equals 2 plus 3 by 4. So 2 unit distance plus uh, 3/4 of a unit distance. So now uh, let's uh, so this is the number line, and we need to have two unit distance. So 2 plus 3 by 4. So let's say this is one unit distance, this is A, and another unit distance is B. So OA is B, distance of OA is B, and distance of AB is OA is 1, and distance of AB is also 1. So this A is actually 1 and this B actually value 2. Now 3 by 4. It is difficult to represent. I need to have uh, let's redraw this. So this is the number line. For the sake of explanation, let me consider this as the origin. Even though it doesn't look like at the mid of the number line, but still just consider that this is the origin. This is value 0. Now this point A is at unit distance from O, so this is 1, and B is also unit distance from A, so this is 2. So and here we have another point C, unit distance from B. So this is 3. So 2 plus 3 by 4 is definitely a value between 2 and 3. So what is 3 by 4? 3 by 4 is if you divide unit distance into 4 equal parts, then 3 such equal parts makes 3 by 4. So if you divide, if we divide BC, this part, into 4 equal parts, since we have 3 by 4 in the denominator, we divide this into 4 equal parts: 1, 2, 3, 4, and 3 such equal parts: 1, 2, 3. So this point will be actually 11 by 4. So up to B we have 2, and then this part is 3 by 4. So this is the way we represent rational numbers on the number line. The same logic you can apply for negative rational numbers, just that if it is negative, you have to draw this on the left hand side of the uh, uh, origin, that is the point O on the left hand side, because the left hand side denotes the negative numbers and the right hand side denotes the positive numbers. Now how do we so now this is rational numbers. Okay, so you might have understood, or you should realize that between any two points, between any two given points on the number line, there are infinite number of rational numbers. Infinite number of rational numbers. See, because from B to C, we have divided the BC into 4 equal parts. I could have divided this BC into infinite number of 100 parts, 200 parts, 200 parts. Then each such equal parts will denote different rational numbers. So you should realize that between any two points on the number line there are infinite number of rational numbers. This will be clear when we discuss how do we find a rational number, find a rational number between two given rational numbers R and S. So if we are given two rational numbers R and S, where it is given that R is less than S. We have two rational numbers R and S. R and S are R is less than S, and R is of the form R and S both are of the form P by Q, and obviously Q not equals to 0. So R and S are any two given rational numbers where R less than S. How do we find a rational number lying between them? So the formula is uh, uh, R plus S by 2 is a rational number that lie between R and S. R plus S by 2 is the rational number that lie between R and S. So we have R less than R plus S by 2 which is less than R. So if we are given two rational number R and S, and we are asked to find a rational number in between them, we can simply say that R plus S by 2 is the rational number between them. Now obviously we are assuming that R is less than S. Now what about if we are asked to find many rational numbers between any two given rational numbers R and S? This is finding a single rational number between two given rational numbers R and S, and find more than one, say n rational numbers between two given rational numbers R and S. How to find more than one? Say two rational numbers or three rational numbers or five rational numbers between two given rational numbers R and S, where it is given that R is less than S. So there are two methods. The first method, the first method is by using the above result, that if we have two rational numbers R and S, then we can have another rational number R plus S by 2 that will be a rational number between R and S. So so to find n rational numbers, what we can do is the first method one is uh, method one is we find the rational number R plus S by 2 which will be less than R. So we are given R and S. So from that we get R plus S by 2 which will be a rational number between R and S. So we found one rational number between R and S. So now obviously R plus S by 2 is less than S. So again now we can find another rational number between R plus S by 2 and S using the same result. Meaning uh, between R plus S by 2 and S I can find another rational number using the same formula. Right? I hope this is clear to you. So R plus S by 2 is a rational number between R and S. So R plus S by 2 is less than S. To find another rational number, I want to find another rational number between R plus S by 2 and S. So I'm applying the same result. I'm adding R plus S by 2 and S dividing by 2. So we are getting another rational number which is between R plus S by 2 and S. So this is the first rational number we have found. This is the second rational number we have found. If we keep on doing this, so we have found this rational number between R plus S by 2 and S. We could have done the same thing with R. We could also find a rational number between R and R plus S by 2, meaning uh, R plus R plus S by 2 divided by 2 less than R plus S by 2. Applying the same result over here, we have found another rational number that is between R and R plus S by 2. So using the same idea, you can keep on finding new rational numbers. So if we were asked to find three rational numbers between R and S, we could have done this. One, the first one is the R plus S by 2. The second one is the rational number between R plus S by 2 and S. Third one is the rational number between R and R plus S by 2. Now, this is method 1, which is a little tedious method, a little lengthy method. There is a more shortcut method, which is method number 2, which is as follows. Now, so the objective is that we are trying to find n natural numbers between two given. We are trying to find n rational numbers between two given rational numbers R and S. So the method 2 is it will depend uh, how the given rational numbers R and S are. Let's say, so since R and S are rational numbers, definitely R will be of the form P by Q, where P and Q are integers and Q not equals to 0, and S will also be something like U by V, where U is an integer, V is an integer, and where P, Q, U, V, these are all integers. This symbol means it belongs to the set collection of Z. Z means the integers, and also P definitely not equals to 0, and V not equals to 0. This will be Q. Uh, Q not equals to 0. Now, mm, if now in the method 2, we need to consider uh, mm, okay, so we have R and S. So R will be of the form P by Q and S will be of the form U by V. Now, what we do is we transform R and S into equivalent rational numbers. By equivalent rational numbers means which gets reduced to the simplest form, the same rational number, like half and 2 by 4 are same rational, are equivalent rational numbers, because 2 by 4 can be reduced to half. So what we do is we transform R and S to equivalent rational numbers. How do we transform R and S? We Let's say when we transform R, the transformed rational number is R dash. I mean, R dash and R are equivalent rational numbers. How do we get that? We multiply Q. Uh, no, first we transform R and S. First, we transform R and S so that they have the same denominator. Now, how do we do with that? We take the LCM of Q and V. Transform R and S. Uh, we transform the rational number RNS, transform RNS to have same denominator. Denominator means over here Q and V are the denominators and P and U are the numerators. So how do we do? How do we do that? Uh, we so we need to find the LCM of Q and V, and that will be the denominator. And whatever value we need to multiply Q to make the LCM, with the same number we have to multiply with P. Similarly, with whatever value V, with whatever value we have to multiply V to have the LCM, the same value we have to multiply with U. For example, if I want to transform half and 3 by 5 to equivalent rational numbers that will have the same denominator, what do I do? The LCM of 2 and 5 is 10. So I need to have 10 as the denominator in both the transformed rational numbers. Now, to make 10 in the denominator in the first rational number, I have to multiply with 5 both denominator and numerator. So half gets transformed to 5 by 2 by 5, and 3 by 5 gets transformed to 3 into 2, 5 into 2. So now 5 by 2 into 5 is an equivalent rational number to is equivalent to half, and similarly 3 into 2 by 5 into 2, this rational number is equivalent to 3 by 5. So 6 by 10. By transforming the two rational numbers to equivalent rational numbers having the same denominator, I mean this process. So they must have same denominator. For that, we need to find the LCM. The LCM of 2 and 5 is 10. So we multiplied the denominator of the first rational number 2 with 5 on with both denominator and numerator. I hope we got the idea. So the same thing, the same transformation we have to apply here. Uh, after transformation, let's say this becomes p dash, and since the denominator will be same, let's say this is d, and s becomes some u dash, and of course the denominator will be same. So r dash is equivalent to r, s dash is equivalent to s, and now they have the same denominator. Now we will from r dash and s dash we will get another equivalent rational number, let's say r double dash, as p dash into n plus 1, where n is the number of rational numbers we need to find between r and s. So we are multiplying p dash into n plus 1 and also d n plus 1. Similarly, over here we will have u dash n plus 1 divided by d n plus 1. So h double dash is equivalent to h dash, r double dash is equivalent to r dash. Now, now we have two rational numbers r double dash and s double dash with the same denominator. Now, so what will be the rational number? What will be the final n rational numbers between r and s? Those n rational numbers uh, will be plus 1 d n plus 1 comma p plus 2 d n plus 1, so on. Since we have to find n rational numbers, this will be the final n rational numbers between r and s. Now this might look complicated. Let me explain through an example. Uh, First, so okay, let's try the example given in the NCERT textbook, which is the example 2. NCERT solved example 2 says find 5 rational numbers between 1 and 2. So We have two methods we have discussed, method 1 and method 2. So if we apply solve this by method 1, how do we solve it? So the first rational number between 1 and 2, we will get 1 plus 2 by 2, which is 3 by 2. So 3 by 2 so is the rational number between 1 and 2. So we have found one rational number. Now if you want to find we have found this one rational number, first rational number. Now let's say we want to find another rational number between, let's say, 1 and 3 by 2. So 1 and 3 by 2. So 1 will be less than 1 plus 3 by 2. A rational number between 1 and 3 by 2 is 1 plus 3 by 2 by 2. So we have this. This is not equals to, meaning this actually becomes 1 less than, in the 1 plus 3 by 2 becomes 2 5 by 2, and in the denominator we have 4. So 5 by 4. So we have found another rational number 5 by 4, which is between 1 and 3 by 2. Now we can find another rational number between 3 by 2 and 2, as 3 by 2 should be less than 3 by 2 plus 2 divided by 2, which is 3 by 2 less than 3 by 2 plus 2 is 4, 7 by 2. So 7 by 4. This is 7 by 4. So we have found another rational number between 3 by 2 and 7 by 4. So we have found this another rational number. So we have found three rational number. Now we can find we can now take into rational number and find a rational number between them, which should be new. Let's say we want let's find a rational number between 5 by 4 and 3 by 2. So 5 by 4 and 3 by 2. So 5 by 4 plus 3 by 2 divided by 2 should be a rational number between 5 by 4 and 3 by 2. This is, if we simplify this thing, this becomes 5 by 4 plus 3 by 2. This becomes 6, 11 by 4. This becomes 11 by 8. So we have found another rational number. All these rational numbers, all these four rational numbers are between 1 and 2. So we need another rational number. So let's consider a rational number between 1 and 5 by 4. So 1 should be less than 1 plus 5 by 4 by 2 less than 5 by 4. So this is equals 1 plus 5 by 4 is 9 by 4, 9 by 8. We have found another rational number between 1 and 2. So this way we have found 5 rational numbers between 1 and 2. I hope you have understood the process. Basically, we are applying the result that between R and S, between two rational numbers R and S, where R is less than S, there is a rational number R plus S by 2 that lie between R and S. This is the concept we have applied for method 1. Now, to solve this problem using the method 2, let's see method 2. So R over here we have R is 1, which is 1 by 1. An integer in the form of rational number means Q is 1. The denominator is 1. Also S is 2, which is 2 by 1. So the denominator is already same. Remember, for the method 2, we first had to transform the given two rational numbers so that the denominators becomes the same. So in this case, denominator is always already same. So now we just multiply the denominator both the R and S by n plus 1. What is n here? N is 5 because we are asked to find 5 rational numbers between 1 and 2. So n is 5 here. So from here we obtain R dash as we need to multiply with n plus 1. Remember, we have to multiply in the transformation, final transformation n plus 1. So we multiply here with 1 into 6 and R dash becomes 2 into 6 divided by 1 into 6. So this is this becomes 6 by 6 and this becomes 12 by 6. So now what will be the rational numbers, 5 rational numbers between R and S? Those numbers will be 6 plus 1 by 6 comma 6 plus 2 by 6 comma 6 plus 3 by 6 comma 6 plus 4 by 6 comma 6 plus 5 by 6 up to 5 because you have to find 5 natural numbers, 5 rational numbers between 1 and 2. So these rational numbers are actually so 7 by 6 and 8 by 6, 9 by 6, 10 by 6, 11 by 6. These are the 5 rational numbers that lie between R and S. You can see that 1 is less than 7 by 6, is less than 8 by 6, is less than 9 by 6, is less than 10 by 6, is less than 11 by 6, is less than 2. So this is the way we find 5 rational numbers between R and S. Here R was given as 1 and S was given as 2. So the denominator both was 1. So we then what was the method 2? If the two given rational numbers have different denominators Q and V, first we have to transform R and S into equivalent rational numbers so that they both have same denominator, that is D. by doing the LCM that I have explained on the right hand side with the example half and 3 by 5. Finally, we get the two rational numbers r double dash and r s double dash by multiplying the denominators with n plus 1. What is n? N is the number of number of rational numbers we have to find. Now, this was simple because r and s are were had same denominator. Let's see another example. Uh, let's try to do okay for finding more than one rational numbers between two given rational number having different denominator. We will see that when we will do exercise 1.1 from the NCERT textbook. Now, so earlier I said that there are infinite number of rational numbers between any two rational number on the number line. Did I mention that? Rational numbers. Okay, I did not mention that. So, as you can see, between any two rational numbers r and s, we know there is a rational number that lie between r and s, that is r plus s by 2. Now, again, we know that there lies another rational number between r and r plus s by 2. So, if we keep on doing this, we will see there are infinite number of rational numbers between any two rational numbers. This is a very important point. There are infinite number of rational numbers between any two given rational numbers. Few more points that I want to address, and you must understand very clearly, are that all natural numbers, whole numbers, integers are rational numbers, and not all rational numbers are integers. Not all rational numbers are integers. Also, not all rational numbers are whole numbers. Also, not all rational numbers are natural numbers, because integers, any integer can be represented. Any integer is a rational number because any integer n can be represented, can be written in the form of p by q as n by 1. So, any integer n can always be written as n by 1. So, it becomes a rational number. And so, all whole numbers, natural numbers, and integers are all rational numbers. But any rational number is not an integer, because say half is not an integer. Minus 3 by 4, minus 3 by 4 is not an integer. So this thing you must keep in mind. And okay, so let's uh, see the example 1 of the NCERT book. Even though the solution is there, try to understand. It says, are the following statements true or false? Give reasons for your answers. True or false? 1. Every whole number every whole number is a natural number. Every whole number is a natural number. What are natural numbers? Natural numbers are 1, 2, 3, 4, 5, 6, 7, 8. These are natural number. Now, every whole number is a natural number. 0 is a whole number, but 0 is not a natural number. So, obviously, the statement is false, because it is saying that every whole number is a natural number. But to contradiction, 0 is a whole number and it is not a natural number. So, this is false. Reason is 0 is a whole number but not a natural number. The second one says every integer is a rational number. Every integer is a rational every integer is a rational number. It is of course true. It is of course true, because what are rational numbers? The rational numbers obviously includes the whole numbers, natural numbers, and the integers. And beyond that, those numbers which can be written in the form p by q, where q is not equals to 0 and p and q are integers. So every integer is obviously a rational number, because every integer n can be written in the form, because the because reason is every integer, let's say n, can be written as n by 1, which is of the form p by q, where q is not equal to 0. So every integer n can be written as n by 1, which is obviously a rational number because it is of the form p by q. Now, the third one says every rational number is an integer. Every uh, every rational number is an integer. This is obviously false, because half is not an integer but a rational number. So like how we will have we can give any other such example, minus of 4 by 3, 3 by 4, whatever. So definitely every rational number is an integer. This is false. Now let's try to do exercise 1.1 questions. It says is 0 a rational number? It says is 0 a rational number? Answer is obviously yes, because 0 can be written as 0 by 1, which is of the form P by Q, where Q not equals to 0. So definitely 0 is a rational number because in 0 can be written as 0 by 1. So 0 is definitely an integer. In every integer we can have 1 as the denominator. So it is of the form P by Q where Q is not equals to 0. So 0 is a rational number. So question number 2 says find 6 rational numbers between 3 and 4. Find 6 rational numbers between 3 and 4. So by using the formula that r plus s by 2 is a rational number between r and s, we will use that. Okay, one thing you must realize that the method 1, that is by using the formula r by r plus s by 2 is a rational number between r and s. If we use this method to find multiple rational numbers like 4 5 rational numbers, 5 rational numbers, then it will be lengthy, because first you have to find a rational number between 3 and 4, and then again between two other rational numbers, then again after between two other rational numbers. So it will be to find 6 rational numbers you have to do similar kind of computation 6 times. It's better to use the method number 2. So we will use method number 2 to find 6 rational numbers between 3 and 4. If we are asked to find a single rational number between any two rational numbers, then we will use the formula r plus s by 2. Now, method 2, we are using method 2. So, R is 3, S is 4. So, our dash is, we are having the same denominator 4. Now, our double dash will be, since we have to find 6 rational numbers, we will multiply with 7. 6 plus 1, 7. 3 into 7, 1 into 7. This will be 4 into 7 and 1 into 7. So now this is 21 by 7 and this is 28 by 7. So the rational numbers, the 6 rational numbers finally will be 21 plus 1 by 7, then 21 plus 2 by 7, 21 plus 3 by 7, 21 plus 4 by 7, 21 plus 5 by 7, 6. We have to find 6. We will have to go up to 6 plus 6. So these are the 6 rational numbers which will lie between 3 and 4. So this becomes 22 by 7, 23 by 7, 24 by 7, 25 by 7, 26 by 7, 26, 7 by 7, and definitely we will have 3 less than this, less than this, less than this, and this, less than this, less than this, less than 4. So we have found 6 rational numbers between 3 and 4 using the method number 2. Now the question number 3 says find 5 rational numbers between 3 by 5 and 4 by 5. So again, by using the method 2, we are given R equals to 3 by 5 and S equals to 4 by 5. So obviously, to make the denominator equal, we already have R dash equals to 3 by 5, or double dash equals to 4 by 5. Now we need to have the same. Now we will find R double dash by multiplying, by transforming the RNS, by multiplying both denominator and numerator with 6. We have why 6? 5 plus 1. How are we getting 5? We have to find 5 rational numbers. So 5 plus 1, 6. 3 into 6 divided by 5 into 6 is double dash is 4 into 6, 5 into 6. This is 24 by 30, and this is 18 by 30. Okay. Hmm. So the rational numbers that will lie between R and S. So the 5 rational numbers will be 18 plus 1 by 30, 18 plus 2 by 30, 18 plus 3 by 30, 18 plus 4 by 30, and finally 18 plus 5 by 30. This becomes 19 by 30, 20 by 30, 21 by 30, 22 by 30, 23 by 30, and obviously we will have 3 by 5 less than, less than, less than, less than, less than, less than 4 by 5. Okay, that was question number 3. Question number 4 is again true or false. True or false. One is every natural number is a whole number. Every natural number is a whole number. Every natural number is a whole number. Yes, obviously. What are whole numbers? What are natural numbers? Natural numbers are the counting numbers, 1, 2, 3, 4, 5, 6, and so on. What are whole numbers? Whole numbers are we just add 0 to a natural number. So 0, 1, 2, 3, 4, 5, 6, and so on. That is the collection of whole numbers. So obviously, every natural number is also a whole number. This is true. What is the reason? Reason is whole number, which is denoted by W, is equals the natural number plus the 0. When we add 0 to this curly brace is a set. Basically, this is a set. Curly brace is a set where we and inside this curly brace we mention the elements separated by comma. This is a set. Uh, Set is a chapter. Uh, I don't know whether you have learned whether you have studied set in your previous classes or not. Some boards like ICSC board have sets. Anyway, so set is a collection of values or elements. Over here, this curly brace and inside 0 means the set contains a single value, that is 0. So when we add 0 to the collection of natural numbers, we have the whole numbers. That is the reason we say that every natural number is a whole number. Uh, mm, okay. 2 says every integer is a whole number. This is false. Because remember, whole numbers are positive numbers. I mean, including 0 and all other positive integers makes the whole numbers. That is the natural numbers and 0. So all those points, including the origin, if you see the number line, the center point origin, which means 0, that point 0 and all other points to the right hand side are the whole number, are the and so 0 and all the natural numbers makes a whole number. But integer, we have integers on the left hand side of the point origin. So negative natural numbers are also integers, but negative of a natural number is not a natural number or is not a whole number. False, because -1 is an integer but not a whole number. Or this is the reason. A better reason will be uh, all negative a better reason is that negative integers are not whole numbers. So negative integers are obviously integers, but they are not whole numbers. This is a better reason. So definitely every integer is a whole number is a false statement. Number 3 says every rational number is a whole number. This is false. Because the reason is every a rational number uh, because a rational number p by q, obviously q not equals to 0, a rational number p and q where uh, p and q are co-prime, where p and q are co-prime, that is they do not have any common factors. Every rational number is a whole number is false because a rational number p by q where p and q uh, are co-prime are not whole numbers. Example 3 by 4. When we say uh, that a rational number p by q, where p and q are okay, one thing you must remember that when we represent a rational number on the number line, we always consider the simplest or the reduced form of the rational number to display on the number line. For example, a rational number can have infinite number of equivalent representation, like half. The rational number half, its equivalent rational number is 2 by 4. Also, another equivalent rational number of half could be 3 by 6. So a rational number has infinite number of equivalent rational numbers. We do not consider those other equivalent rational numbers. We only consider half, the reduced and the simplest form. So when I am saying that a rational number p by q, where p and q are co-prime, I am saying the rational number p by q is in the simplest form or is in the reduced form. So in that case, p by q are not whole numbers. Example 3 by 4 is a rational number, but then it is not whole number. Even minus half, like this, 5 by 6, whatever this, etc. So that brings to the end of the lecture 1. We have completed exercise 1.1 and I have explained the two solved example 1 and 2 uh, of the chapter 1 number systems, and from lecture 2 I will start the irrational numbers. Now based on what I've discussed in lecture 1, I've prepared an assignment sheet. The link of the PDF I will attach in the description below. Please try to solve the problems in the assignment sheet, and before that you see my video, understand the concept, and then only try to solve the assignment problems. While solving the assignment problems, please do not see the book or the notes. You first prepare the notes by seeing my lecture, this video, or the textbooks, and then try to solve the assignment problems. Uh, Try your best, give multiple attempts, and only when if you are not able to solve it, uh, then you will you can see my solution which I will provide in the next 24 hours. Thanks for watching. I will be regularly posting videos uh, sequentially, uh, the chapters that is as it is given in the NCERT textbooks. I will discuss the solved examples, and I will also solve the exercise problems chapter wise. So stay tuned with my channel, and if you find this video useful to you, if you're learning something, then please support me by subscribing to my channel and like this video and share my channel and this video with your friends. And also do not forget to press the bell icon so that you will be notified by my future videos. So that's it. Until the next video, take care and bye.